Ford produces thousands of vehicles in a day using their assembly. Ford Motor Company has long been a pioneer in automotive production, revolutionizing the industry with its innovative assembly line techniques. From the moment raw materials enter the facility to the final inspection of each completed vehicle, every step is optimized for speed and precision. This is a deep dive of the step-by-step process inside Ford massive factory. The first stage is material preparation, and that starts with laser cutting, where large sheets of steel are precisely cut into specific shapes required for automotive body panels. This method is favored for its high accuracy and efficiency, allowing manufacturers to create intricate designs while minimizing waste. The precision of laser cutting ensures that each panel meets exact specifications, which is vital for proper fitment during assembly. But recently, Ford has been adapting to using aluminum body parts, and just like the metal cutting process, aluminum goes through the same process. Then they get sent to the main assembly line. On the main assembly line, the Fanut's robotic arms are calibrated in independent cells before being put into the production line. This structured approach to calibrating Fanuc robotic arms in independent cells allows manufacturers to maintain high standards of quality and efficiency in their automated processes. Fanuc robotic arms typically feature a 6-axis design, allowing for a wide range of motion similar to that of a human arm. This configuration enables the robots to perform complex tasks such as assembly, welding, and material handling. Once the body panels of a vehicle are joined together through welding, the body structure undergoes a critical alignment process to ensure that all components fit correctly and function as intended. Ford uses the body-on-frame construction method, where the vehicle's body is built separately from its frame. In body-on-frame construction, a robust frame serves as the foundation for the vehicle. The frame supports critical components such as the engine, drivetrain, suspension, and wheels. The vehicle's body is then mounted onto this frame, allowing for a distinct separation between the two. After the body panels have been welded and assembled, the vehicle structure is submerged in a dip tank, which typically contains a heated alkaline solution that effectively removes oils, grease, dirt, and other contaminants from the metal surface. The Ford car then undergoes priming and base coating using an automated robotic system. The primer is applied using robotic arms equipped with advanced spray technology. These robots can precisely control the spray pattern and volume, ensuring even coverage across all surfaces. The robotic system is often integrated with vision technology that allows the robots to adjust their application based on real-time feedback, ensuring consistency across different body styles and configurations. Then, similar to the primer application, the base coat is applied using robotic arms. The robots use programmed paths to ensure that every area of the vehicle receives an even layer of paint. The primer is essential for ensuring proper adhesion of subsequent paint layers and enhancing the overall durability and appearance of the vehicle. The clear coat is finally applied using robotic arms equipped with advanced spray technology. Depending on the desired finish and durability requirements, multiple layers of clear coat may be applied. This process not only enhances the visual appeal of the vehicle, but also provides essential protection against environmental damage, ensuring that the vehicle maintains its appearance over time. Automated inspection systems are employed post-application to check for consistency in gloss and thickness across different panels. Any areas that do not meet quality standards can be flagged for rework. During this process, the doors of the car temporarily fitted in to make the process easier.
The cubes incline 45 degrees to present the door panel to the Spotwell robot.
And the door assembly line at Ford stands as a testament to the ingenuity and innovation characteristic of modern manufacturing practices. At the core of this operation are 24 state-of-the-art robots, along with a variety of cutting-edge machines that work in perfect harmony, creating a highly synchronized assembly process. This remarkable system possesses the capability to handle 6 different types of car doors simultaneously, showcasing its versatility and efficiency. Utilizing advanced rotating tooling fixtures, complemented by gantry transfer robots that glide seamlessly along the assembly path, the entire setup is meticulously designed to maximize both operational efficiency and workplace safety. The line aims ambitiously to produce an astonishing 120 doors every hour, which translates to a new door rolling off the line every 30 seconds, a truly impressive feat in automotive manufacturing. The journey of the door assembly process commences with a vital initial step. The manual loading of the door's inner and reinforcement components onto specialized rotating tooling fixtures, thereby establishing the groundwork for the subsequent assembly stages. Once the components are securely in place with initial welding, the door transitions into a series of automated steps that significantly enhance productivity. This is where the real magic of robotics comes to life. Structural components are expertly integrated into the door design, while high-quality adhesives are applied with remarkable accuracy, all thanks to sophisticated robotic systems. These systems ensure that each operation is executed with exceptional precision, creating doors that not only meet but often exceed industry standards for quality and durability. So after the coating, these doors are removed and transferred to a secondary assembly line for the electric lining installation. So wires are fitted in. Wiring harnesses are bundles of wires that transmit electrical signals and power throughout the vehicle. They are designed to simplify the installation process and reduce the risk of electrical faults. The wiring harness for power windows and other electrical components like window switches needs to be connected. This typically involves plugging in connectors that were disconnected during panel removal. An automotive-grade adhesive sealant is applied to the window glass, which is a critical process, particularly for ensuring a strong bond and weatherproof seal. Window regulators are installed in the door frames before the windows themselves are positioned. These regulators are typically electric and require wiring to connect to the vehicle's electrical system. The windows are carefully positioned into their respective doors by skilled workers. Each component is typically scanned before installation to ensure quality, compatibility, and precision. Handheld barcode scanners are used to read the unique identifiers on components. This technology verifies that the correct parts are being used for each specific vehicle model. The installation of tires on chassis at Ford's assembly line is another vital component of vehicle production that is done at the assembly line. This meticulous operation is designed to optimize production while ensuring that quality and safety standards are consistently met. The process begins with the preparation of components, where rims are fed into the assembly line and prepped for tire installation. Each rim is fitted with a valve essential for maintaining tire pressure. Following this, tires are introduced into the assembly machine, ready to be mounted onto the rims. Once the components are prepared, robotic fitment stations are employed to mount the tires onto the rims with precision, enhancing accuracy while reducing manual labor. Balancing is another critical aspect of this process. Automated systems measure and adjust weights as necessary to ensure optimal ride quality, which is vital for vehicle performance and customer satisfaction. Finally, rigorous quality control measures are implemented after balancing. Each tire and wheel assembly undergoes thorough inspections to ensure compliance with safety and performance standards. With approximately one fitted wheel and tire coming off the line every 15 seconds, Ford's assembly line exemplifies efficiency and innovation in automotive manufacturing, reflecting the company's commitment to delivering high-quality vehicles to consumers worldwide. After this, the important process of fitting the engine happens. The installation begins with the engine and transmission being assembled as a complete unit. This method allows for optimal alignment of the torque converter or clutch with the engine flywheel before they are mounted onto the vehicle's chassis. To facilitate this process, the engine mounts are unbolted from the engine block, providing additional clearance for maneuvering. Once adequately prepared, the engine is carefully slid back into place on the assembly line. This step requires precision, as it involves aligning the torque converter or clutch splines with the engine flywheel. To achieve this alignment, jacks may be employed to adjust the transmission's position vertically, ensuring that dowel pins on the engine block fit securely. After successfully mating the engine with the transmission, technicians proceed to bolt them together. The motor mounts are then reinstalled, and the engine is lowered onto its designated brackets on the frame. This careful coordination ensures that both components are securely attached and positioned correctly. With the engine now firmly in place, attention turns to installing various accessories essential for vehicle operation. Components such as the alternator, power steering pump, and air intake are added after the engine installation to allow better access and avoid complications during assembly. Following this, fluid lines, wiring harnesses, and other necessary connections are meticulously attached to ensure that all systems will function properly once the vehicle is operational. The final touches involve installing front-mounted components like the radiator and fan shroud, which are critical for cooling and overall performance. After this, the installation of a dashboard in Ford vehicles begins with thorough preparation. This phase involves gathering all necessary components, which include the dashboard assembly, wiring harnesses, and various fasteners. Quality assurance checks are conducted to inspect each part for defects or damages. Ensuring that all components meet the required standards is crucial to prevent any issues during the installation process and to maintain overall vehicle quality. Once all components are ready, the next step is positioning the dashboard within the vehicle's frame. This is typically achieved through a combination of automated systems and manual labor, depending on the production line setup. Workers or machines carefully align the dashboard with the vehicle's mounting points to ensure that it fits correctly. Proper positioning is essential as it sets the stage for a secure installation and ensures that all features will be accessible once the dashboard is in place. With the dashboard positioned correctly, the next step involves connecting the electrical wiring harnesses. These harnesses link various dashboard components, such as gauges, infotainment systems, and climate control units, to the vehicle's electrical system. Technicians meticulously check each connection to ensure that they are secure and functioning properly. This step is vital because any faulty connections could lead to malfunctions in critical vehicle systems once the car is operational. After all wiring connections are made, the dashboard is secured in place using bolts and screws at designated mounting points. This process often involves adhering to specific torque specifications to ensure that all fasteners are tightened appropriately without risking damage from over-tightening. The secure attachment of the dashboard not only contributes to the aesthetic appeal of the vehicle, but also plays a significant role in passenger safety by ensuring that all components remain firmly in place during operation. As the vehicle moves along the assembly line, workers are positioned at specific stations to perform dedicated tasks related to seat installation. The first step involves bolting the seat frame securely to designated mounting points on the vehicle floor. Following this, workers connect electrical components such as wiring for seat heaters and power adjustments. This division of labor allows each worker to focus on specific tasks, enhancing both speed and precision during the installation process. To further streamline seat installation, Ford employs a mix of manual labor and advanced tools. Power tools are utilized for quickly securing bolts, ensuring that each seat is firmly attached to the vehicle structure. Additionally, automated clinching tools may be used for installing trim pieces, which helps to maintain consistency and speed throughout the process. This combination of human expertise and technology is essential for achieving high production rates while adhering to quality standards. The next step is the installation of the grille, but before installation, all necessary parts, including the grille assembly and mounting hardware, are gathered at the workstation. The vehicle chassis is then positioned on the assembly line, allowing workers easy access to install the grille alongside other components like the engine and front bumper, ensuring a seamless fit. Once the vehicle is ready, workers align the grille with pre-drilled holes in the front of the vehicle. This alignment is crucial for proper installation as it ensures that all fasteners can be securely attached. Workers typically use tools such as torque wrenches to tighten screws or clips to specified torque levels, ensuring that the grille is firmly held in place. After securing the grille, they press or snap it into position. Utilizing trim tools if necessary to engage lock tabs or clips effectively. Alongside the grille installations, other decorative parts are added like badges. Following installation, final adjustments are made to ensure that the grille aligns perfectly with surrounding body panels. Quality control checks are conducted to verify that the grille meets design specifications and is securely attached. Once these checks are completed, the vehicle continues down the assembly line for further installations, embodying Ford's commitment to efficiency and quality in manufacturing. After all of this process, Ford employs a meticulous visual inspection process on its assembly line to guarantee the quality and reliability of its vehicles. This process begins at the end-of-line quality control station, where each vehicle undergoes a comprehensive inspection. Inspectors scan the vehicle's barcode to access a tailored checklist specific to the model, guiding them through various control tasks. They utilize multimedia resources, such as instructional videos, to ensure thoroughness and accuracy during the inspection. To maintain high standards, Ford implements random sampling of vehicles for quality checks, ensuring that a representative selection is thoroughly examined. This approach helps identify defects that may not be apparent in every unit produced. The inspection includes both static and dynamic audits. The dynamic audit involves driving the vehicle on a predetermined route to test all systems, while the static audit focuses on a physical examination of surfaces, measuring panel gaps, and confirming that all components are securely fastened. Once the vehicle has completed the assembly process, it enters the final inspection stage. This initial phase involves a thorough examination of both the exterior and interior components. Inspectors check for paint imperfections, body alignment, and any visible defects. Inside, they verify that all interior features, such as seats, dashboard elements, and electronic systems, are correctly installed and functioning as intended. This step ensures that any obvious issues are addressed before further testing. After the initial checks, the vehicle undergoes a series of functional tests to evaluate its performance. This includes starting and stopping the engine multiple times to assess its responsiveness and efficiency. Steering alignment is also tested to ensure proper handling characteristics. Additionally, the braking system is scrutinized for effectiveness, ensuring that it meets safety standards. These functional tests are critical for identifying any operational deficiencies early in the inspection process. Following the functional tests, specialized inspections are conducted to assess specific systems within the vehicle. Electrical systems undergo rigorous testing to confirm that all components function safely and efficiently. Leak tests are performed using high-pressure water to identify any potential leaks in critical areas such as the engine or fuel system. Headlights are also evaluated to ensure they meet brightness and reach specifications, contributing to overall driving safety. All findings from the inspections are meticulously logged into a quality management system. This documentation allows Ford to track defects and implement corrective actions swiftly. If any issues are identified during inspections, the vehicle is sent to designated repair stations where trained technicians address these problems. Once repairs are completed, the vehicle is subjected to re-inspection to verify that all issues have been resolved satisfactorily. Upon successful completion of inspections and repairs, a final approval is granted before the vehicle is prepared for shipment to dealerships or customers. This comprehensive inspection process not only ensures that each Ford vehicle adheres to high-quality standards, but also enhances overall safety and customer satisfaction. By maintaining rigorous quality control measures, Ford reinforces its commitment to delivering reliable vehicles that meet consumer expectations. And this is a necessary thing to do, especially for Ford, since the company has been dealing with a series of recalls that shine a glaring light on the urgent need for better quality assurance processes. specifically right at the end of their assembly lines. We're not just talking about a small hiccup, each recall makes waves, and right now, over 550,000 F-150 pickups are being recalled due to a serious issue involving faulty transmissions. Imagine being behind the wheel and suddenly experiencing an unexpected downshift. That's a recipe for losing control and potentially facing a crash. This isn't just a one-time incident either. Ford has already rolled out 37 recalls in 2024 alone, which is the highest number among all US manufacturers. It raises some serious concerns about systemic quality control failures within the company, and this is not good Ford. Just in one quarter, Ford reported shelling out around $2.3 billion on recalls and warranty costs. That's a massive weight on their finances, and highlights how serious these quality issues are. When you compare Ford's costs with other automakers like GM, especially during their Bolt recall, it's clear that Ford's expenses are on a whole different level. These costs hit harder than just the bottom line. They also chip away at consumer trust, which is vital for building long-term loyalty to the Ford brand. The safety concerns that arise from these recalls are equally worrisome. Engine failures and transmission problems don't just stay under the hood. They have real-world implications for the safety of drivers and passengers. Some of the complaints tied to these issues have even resulted in injuries and crashes, which is a major red flag. As if that wasn't enough, the growing number and seriousness of these recalls have raised eyebrows about Ford's reliability. Models like the Explorer have often been spotlighted in assessments as some of the least reliable vehicles out there, and that's not the kind of reputation any car company wants to have. So what can Ford do to tackle these challenges? It's essential that they step up their game and put substantial investment into rigorous quality assurance measures right at the end of their assembly lines. Ford's chief financial officer has hinted that improvements in production quality are on the horizon, expected to roll out over the next 12 to 18 months. However, waiting that long isn't really an option if they want to regain consumer confidence and ensure safety on the roads. Without significant upgrades to their quality assurance practices, Ford risks facing even more recalls, financial hardships, and, let's be honest, serious damage to their reputation as a trustworthy automaker. With stakes this high, there's no time like the present for Ford to make the changes necessary for a safer, more reliable future. And on top of this, Toyota is doing the better job. The historical rival is making more reliable cars. See, Toyota emphasizes the principle of quality built in, meaning that quality assurance is integrated into every phase of the production process. Each employee is responsible for the quality of their work, and they are empowered to stop the assembly line if they detect a problem. This proactive approach ensures that defects are caught early and do not progress to the next stage of production. And Toyota's commitment to continuous improvement, known as Kaizen, is fundamental to its operations. The company regularly reviews and updates its quality standards based on customer feedback and internal audits. This culture of constant evaluation allows Toyota to adapt quickly to changing customer expectations and industry standards. When issues arise, Toyota employs systematic problem-solving techniques such as the 5 Whys method to identify root causes rather than just addressing symptoms. This thorough analysis helps prevent recurring problems and enhances overall product reliability. So maybe Ford is trying to make their assembly lines as efficient as Toyota when it comes to reliability. Who knows? Only time will tell. Thanks for watching this video, and I will see you on the next one.